I'm Jared Harrington, and today I will be discussing Lab 4 circuits. So to begin, the objective of this lab was to predict the behaviors of circuits containing resistors in series and parallel structures. Use a multimeter to measure the actual values of the conventional current and potential differences in the circuit, and also to examine the behavior of ohmic resistors and capacitors. So some important physics principles within this lab were the loop rule, which states that the total voltage within a circuit will be equal to zero. And then the node rule, which states that a current in equals a current out. Ohm's law, which the voltage equals the current times resistance. Steady state, capacitance, and then the conservation of energy and charge. So for an overview of series circuits in this experiment, the system would be the circuit, the surroundings would be everything outside of the circuit, and then the goal for this section was to predict the currents of I1 and I2 within the circuit. So how you do this is the two batteries both equal 1.5, so you multiply them by 2 and you get 3 volts, and then you add the total resistance, which is 47 plus 100, and that'll give you 147. And then using Ohm's law, you can determine the current, and the current is equal to 0.02, and the current would be the same everywhere. So I1 equals I2. So for this section, we had to measure the potential difference between each labeled point in order to satisfy the loop rule. And then as you can see, these are the potential differences at each spot. And if you add all of them together, it would be equal to zero, which means the loop rule is satisfied. And then here is the setup of the series circuit. And then this is a plot of the potential difference. And then as you can see, the loop rule is satisfied within the graph as it starts off at zero and ends at zero. And then moving on to RC circuits. So in this section, we had to determine the amount of time it takes for a light bulb to charge and discharge in the circuit. And then using a 10 ohms light bulb, it took 12.2 seconds to charge and 11.05 seconds to discharge. And then using the 20 ohms light bulb, it took 23.07 seconds to charge and 24.85 seconds to discharge. So then from there, you use this equation in order to find the slope. And then the observed RC would be 2 in this case, and then the experimental would be 1.7921. And then for this part, you basically do the same thing, and then the observed was determined to be 4, and then the experimental was 3.803. And then this was our setup for the RC circuit. We had a better one, but it got deleted, so I had to use the virtual figure. And also, we encountered multiple problems within this section, and more on that on the next slide. So for some errors of this lab, obviously there were human errors, but for my group, the main issue we encountered was equipment failure. Compared to most other groups, it took us a lot longer to complete this lab because we encountered broken light bulbs and our voltmeter and ammeter were not reading accurately. And so for the RC section, we were able to complete the lab in person, but I wasn't confident that the results were accurate, so I used the online model for this section. So yeah. So since I did this lab in person, instead of discussing the as if I did this in person, I'll be discussing as if I did this online. So if we used online ammeter, it would assume that there would be no resistance within the circuit, and it would cause the current values to go up. And that's the first question. And then for the second question, it would assume um, that the wires and the capacitor have no resistance. and it would cause the time for the light bulb to charge and discharge to be quicker than what it actually is.